So on number 15, they give us, it says, what value should be assigned to f of 2 to make the extended function continuous at x equals 2? Well, if you look at the picture that they give us for that, if we want this to be continuous at x equals 2, well, it's not continuous because there's a hole there. True. There's a limit, but there is no function value. So therefore, it's a removable discontinuity, though, just based on the fact that it has a limit there. It's a hole. Okay. And so the question is, what value could we assign to x equals 2 so that the hole will get filled? It'd be 0. If we put in the point 2, 0, that would fill the hole, wouldn't it? That's all they're after. What else through 23?
23B.
And part B says which are removable and which are not removable. So once again, in our picture here, if we look at this one, okay, is this one removable? Yeah. Okay, and we wouldn't, this one already has a value assigned for x equals 0. It's assigned as 0, 1. Okay, what we'd want to do is instead of assign, it's already been assigned, so we'd have to reassign it. So we could change the assignment of the 0 point and make it 0 up. Make it 0, 0 instead of 0, 1. So we could reassign that point. That'd be the way we could do it. But what about 1? Can't do 1 because 1's a jump. Okay, really the only way that we can do that, either assigning or reassigning, is if there's a limit at that point. If there's no limit at that point, then we got other issues, right? Okay. So in order to reassign that, okay, we would rewrite they didn't give us a formula for this piecewise function, but if there was, currently it would have 0, 1. We would just assign it 0, 0 instead. And we just change the assignment. Okay.
27.
Anything else on 23 before we move on?
Is there anything like special that we have the right to reassign it? Like saying that we're reassigning that?
No. In fact, I don't. Trying to think. I don't think there are any problems where we do where we actually have to do the reassigning. Okay. It is removable because we could just rewrite the function with that point assigned to a different spot. So, and make it continuous that way. What else? 1 through 23. All right. How about next part? 25 through wherever the end. 27. On 27, they ask us to write the extended function for f of x equals sine x over x. And ultimately, we know we have an issue here at 0. Okay, if we investigate that function, which we've already investigated this function, okay, we hopefully remember that this function has a hole at 0. Okay, and remember the picture that we looked at when we looked at this special function at 0. The hole was at what y value? It was 1. We said the limit of this as x approaches 0 is 1. Always, it's for a special function sine x over x. And so with that said, if we want to write the extended function that would fill in the hole, and again, we would still write the same function itself except for x not equal 0. Okay, so anywhere x doesn't equal 0, we're going to use our same function. But when x equals 0, what value do we want to assign to that x value? 1. And we're done. So that's all we're asking for.
Did you write the answer like that? Or did you just say one?
You need to write the answer like this. So this is the extended function that would essentially fill in the hole. What else? George?
29.
And 29, we have similarly, we have an issue with our x minus 4 over x square root of x minus 2. And the issue point here is 4 because we know if we put a 4 in there, we're going to get 2 minus 2, which is no good. And so we can investigate this, and if we did investigate it graphically and tabular using a table, we would see that it is also a hole here. So the question is, can we fill the hole in? Well, to fill in the hole, we need to find the limit. So to find the limit, we could directly evaluate, but again, the direct evaluation would give us the issue of 0 on the bottom again. So is there any algebra that we can do as the next question so that we could get that into a form where we could plug in that 4 value? Because right now we can't. Well, generally when we have radicals, a good strategy using radicals would be to change the radicals by multiplying by the strategic binomial that I just wrote, which is called the How did you get? And so if we can see that, going backwards here a little bit, you know, I have it going by 0.5s here, but ultimately we have the 0.01 as a point. If we plugged in 0, we would get 1. Okay. And then we can also see that if we plugged in a 1, we'd get negative 0.6321. And right there would tell us that there's a solution here, because what's going to have to happen between these two x values, knowing that the y values change sign? Okay. It had to cross the x-axis, didn't it? Okay. So we could say ultimately since it says explain, so we should write words here. And that's kind of a general rule for any time we have a sentence that says explain something. Okay. Explain something requires words. Okay. So we see that in a quiz or test, and use words when it says explain. So we can say since between x equals 0 and x equals 1, we have sign change. And what can I say after that? Since we have between x equals 0 and x equals 1, we have a sign change. What must have happened? There has to be a 0 between there. And is that all I need to write? Since we have a sign change, so we have a 0. Can I just write, so we have a 0 here? Okay. So think about explaining it. Why do we know that that's a fact? Right? Based on the math that we've learned in the last couple of days. Ultimately, it's actually not theorem 7, but theorem 6. We, these two together make a what kind of function? Okay, these two together, e to the negative x minus x. Okay, what kind of function is that? Okay, what does this depend on, this whole business of sign changes? Depends on whether this is what? It's continuous or not. So since this is a continuous function, true? So since e to the negative x minus x is continuous, then what guarantees that there's a 0 between 0 and 1? What theorem guarantees it? Intermediate value theorem. And when you have a quiz or a test, you need to be able to talk about the intermediate value theorem. So if the answer is the intermediate value theorem and you put the IVT, okay, not going to be good enough. Okay, so it's the intermediate value theorem. If you put the median value theorem, not going to be good enough. So in other words, make sure you know how to talk about the intermediate value theorem and be able to name it correctly. Okay? So it's the intermediate value theorem. So if you don't have that memorized at this point, it's a project for today. So ultimately, since e to the negative x minus x is continuous, the intermediate value theorem guarantees what? Oops, guarantees, I should say. Guarantees a 0 between x equals 0 and x equals 1. So that would be a valid explanation. And again, is that the only thing I could say? I mean, does it have to be exactly those words? It's your explanation as long as you invoke the intermediate value theorem and the fact that the function is what? Continuous. If you don't talk about the continuity, then the intermediate value theorem doesn't really do you much good, does it? Right? Because ultimately the intermediate value theorem wouldn't even apply if it wasn't a continuous function. So that's the underlying issue, is making sure we understand that that's a continuous function. What else? 43, we're going to skip that one. You can go ahead and cross that one out. What else? 39. Alright, on 39, we have fairly similar to what we just did here. It just says, is any real number exactly less than its fourth power? And if so, give any such values accurate to 3 decimal places. So the question is there any real number, okay, exactly 1 less than its fourth power? So with that said, think about an algebra sentence that would equate to that. Okay, is there any x that would be 1 less than its fourth power? Wouldn't that be the math way to write the question? Okay. So is there any number, we don't know the number, okay, but is there any number that's less than 1 less than its fourth power? So the question is there a solution to this, is what it boils down to. Okay, and so if we look at our, if we write it as a polynomial here, we'd want to know, is there a solution to this sentence? Okay. Well, let's take a look. If we investigate this function and its zeros, x to the fourth minus x minus 1, and we look at the, start with the graph here, looks like we can see that there is, in fact. Okay. Okay. So there are, and ultimately the solutions we can find here with a 4th degree equation. We don't have a quadratic or a quartic formula. We don't. There is a quartic formula, but it's too much of a pain in the neck for us to know about it at this point. But ultimately, if we can't find a nice solution to this, there's really going to be no way we could break this down and find those. And since they specifically told us that if there is, to find them to the nearest 3 decimal places or whatever, okay, then at that point it just becomes a calculator problem. So hopefully at this stage in your career, you know how to use the 0 command. And the first one, oops, yeah, screwed that up. Try that again. So if you go left, right, and center on your 0 command, should be negative 0.724. And one thing that even in calculus class, I need to say, because I still mark half points off for people that are not rounding correctly. Okay, if we had to round this to the nearest thousandth, which ultimately is going to be our general rule in this class, so at this point, okay, start putting that in your mind. If what you have is not rounded to the nearest thousandth, and then it's not rounded correctly. And the only time we won't round to the nearest thousandth is if it tells us specifically to round it to something else, okay, or if it's money. Money, what should it be? Nearest hundredth if it's money. But on this problem here, if we had to round this, it would be negative 0.724. Okay, because if we look at the tenths or the hundredth, the thousandths place, it's a 4, and what's right next to it? Another 4, which is not 5 or higher. You know, some people say, wait a minute, there's a 9 there. Wouldn't the 9 make the 4 into a 5, and then the 5 make the 4 into another 5? No. Okay, we're not even looking at that 9. If we're rounding to the nearest thousand, okay, we only look at the number that's right next to it. Okay, never mind what's behind that one. Okay, that's irrelevant. Okay, so when we look at our 4, there's a 4 behind it, so it doesn't change. So our answer would be negative 0.724. So make sure we round numbers correctly, otherwise we lose points every time we don't. Okay. Anything else on the homework assignment from yesterday? Yes, we'll go to that. Anything else in the book before we move on to the packet? Okay, packet problems. Looks like we had 54 through 59. I'll read the answers just in case your copies aren't very good. 54 should be false. 55 is false. 56 is B. 57 is E. 58 is A. And 59 is E. Okay, so how about questions? Said 55 we're talking about. So on number 55, it tells us true or false. It is possible to extend the definition of a function f at a jump discontinuity x equals a, so that f is continuous at x equals a. Okay. So we talked about that a few minutes ago. Is it okay? Are we going to be able to reassign anything if it's a jump discontinuity? No. Okay. So answer ultimately is false. And really, the major issue here is because they're at a jump discontinuity, there is no there's no limit. In order to have a fill in the blank for a hole, okay, there has to be a limit there first, otherwise there's no chance of us removing it. Fair enough? Anything else from the packet problem? On 56, it says, on which of the following intervals is 1 over radical x not continuous? So 1 over radical x, we can see that we're going to have a discontinuity here. The problem is going to be when we have a 0, number 1, okay? Or also anything what? Anything negative. Okay? So if we look at the domain of this, the domain here would be 0 to infinity then, wouldn't it? But once we get by 0, anything to the right of 0 is going to be okay here. We'll be able to get a valid y value if we stick in anything x that's bigger than 0. True? So in terms of which interval to choose here, if we look at choice A, it has 0 to infinity exactly the way I have written here, the actual domain. Okay? And we would say yes to that. It's going to be continuous on that whole domain. And if you look at C, D, and E, all those are good. Guess the issue is why is B not good? Yeah, it includes 0. And 0 is not okay here. We can't have 0 on that, so therefore that's going to be the one that's not correct. Every other one of those intervals falls within this, and so therefore we know that on this one we're good on all of that. Anything else in the packet?